Hi again. As I told you, I'm going to explain how to find the vertical asymptote. Due to the video that I've just posted, vertical asymptote means that a certain function will approach, and approach means limit. So if a limit of a certain function approaches either positive or negative infinity, when the values of x are approaching a certain value from the right side or from the left side. So if limit f of x as x approaching a from right or left gives you either positive or negative infinity, this means that the line x equals a will be considered as a vertical asymptote. Now, how does that work? From where would I find that value of a? Okay, since the function will never touch that value, this means that this value does not belong to a domain of the function. So basically we have two exceptions of the domain of function. The first exception is when you have a number over 0 or when you have a negative under radical, a square root or fourth root, even root. Even roots, since the undefined values are negative values, so it's not even a real number. So that will not be a case that to study for vertical asymptotes. Actually, what we need to study for vertical asymptotes is the zeros of denominator for a function. So for example, if I have a function like 1 over x minus 1, what are the values that does not belong to the domain here? It's when you solve x minus 1 equals 0, so you will get x equals 1. So we have a possible value here, which is x equals 1. This is a possible value where we may have a vertical asymptote. How to check that? That's simple. Just evaluate the limit of the function when x approaching this value 1 from either side, right or left. I'm going to choose the right side, for example. So let's say I need to evaluate this. You know that the basic thing to evaluate a limit is a direct substitution. So if you do direct substitution, we'll get 1 over 0. 1 over 0 means the limit does not exist, and that will actually be equal to infinity or negative infinity. A number over 0 will always give you either infinity or negative infinity. Now, how can I check if it's positive or negative infinity? Because that will help me when I need to graph the function. I'm using here 1 from the right. 1 from the right means a very close value to 1, like 1.1, for example, 1.01. Okay, let's say I'm gonna substitute here 1.1. So what will you get? 1.1 minus 1. That will give you a positive value. So actually I'm talking about a positive number here. So positive divided by positive will give you positive infinity. So here I know that the limit will approach positive infinity when x is approaching 1, which means I'm having a vertical asymptote at x equals 1. This will be a vertical asymptote. This is enough to decide that I have a vertical asymptote. But actually, checking the right side or the left side may help me in the graph, as I said. So I would prefer to find the other side just to show you how would that affect the graph of the function and how would that help you. So let's say I'm gonna evaluate limit of 1 over x minus 1 as x approaching 1, but in this case from the left side. What would I get? I'm gonna get again 1 over 0, but the only difference will be with the sign. So if you are using 1 from the left side, this means I'm talking about 0.99, for example. So 0.99 minus 1, that's a negative value. So I'm talking about positive divided by negative, which is a negative infinity. Now, What does that mean for me, for the graph? Let's say, for example, I'm talking about x equals 1. Okay, so at x equals 1, I'm gonna have a vertical asymptote. Okay, I'm gonna have a vertical asymptote at x equals 1, and according to my results here, when I'm approaching 1 from the right, the function is approaching infinity. So when you approach 1, let's say as a sketch only, when you approach 1, the function will approach was infinity. When you approach 1 from the left side, the function will approach negative infinity. So we may get such a graph, something like this. That's for vertical asymptote as a basic info. Now, does that mean that all the zeros of denominator will have a vertical asymptote? Let's check. Let's say we have an example like f of x equals x minus 1 over x squared minus 1. In this case, the zeros of denominator, x squared minus 1 equals 0, so x squared equals 1. When you take a square root, you will get x equals plus or minus 1. Does that mean that I'm going to have vertical asymptote at 1 and negative 1, which means 2 vertical asymptotes? Well, we cannot decide until we evaluate the limit. So let's check limit. What's our function? X minus 1 over x squared minus 1 as x approaching 1. If you evaluate this, that will give you 0 over 0, which means you need to work more. So limit x minus 1 over, factorize the denominator, and this will lead to simplified expression. So x minus 1 can be cancelled with x minus 1. This will give you limit 1 over x plus 1 as x approaching 1. When you evaluate that, you will get 1 over 2, which means it's not infinity or negative infinity. So the main result here is no vertical asymptote at x equals 1. Well, now 1 is not a vertical asymptote. What about negative 1? Let's check that. Limit x minus 1 over x squared minus 1 as x approaching negative 1. What would that give you? Of course, we need to check either right side or left side. Either right. In this case, it doesn't make a difference because it gives us a value, not an infinity. But here, let's say right side of 1, of negative 1, this gives me negative 2 over 0, which leads to infinity. Now, we just need to check whether it's positive or negative infinity. Negative 1 from the right side, this means negative 0.9, for example. So negative 0.9 squared, that's something less than negative 1. So it's negative over negative means a positive infinity. So what does that mean? This means that x equals negative 1 is a vertical asymptote. What's the result that we should know here? That we don't have, it's not a must to have a vertical asymptote at the zeros of denominator. These are only possible values that we may have vertical asymptote at, but it's not a must. We need to check the limit from right or left for the numbers, either right or left. In this case, I used right for both. And that's it. Good luck.